Here we have evaluating trigonometric functions. And so really with all the operations, addition, subtraction, multiplication, division, we have various, expressions that can be simplified, again, using the ratios that we already know. So here, first, example here I would have is cosine of pi over 2 plus sine of pi over 2. And question number 2, we can look at something like cosine of pi over 6 plus sine of pi over 4. And then for question 3, we have something like sine of 3 pi over 2 times by sine of pi over 2, and then times by tangent of pi over 2. So now let's look at the first one, cosine of pi over 2 plus sine of pi over 2. So again, we're looking at this. If you remember the idea that as the angle increases and you take the cosine of that particular angle, the overall ratio, that overall value that you get will decrease, whereas for sine, really it's going to increase as you take a larger value. Well, pi over 2 is really in quadrant 1, I guess you would say, right? So, and it's really the largest angle within that quadrant. So really for sine of pi over 2, it's going to have the largest possible value for sine, and for cosine it's going to have the smallest possible value. And if you recall, really the range for both of these functions starts from -1 and goes up to 1. So cosine of pi over 2, if you remember from the unit circle, that is 0. Sine of pi over 2 is 1. Therefore, your answer is 1. Moving on to problem 2, we have cosine of pi over 6 plus sine of pi over 4. If you again recall that same concept, that again taking an angle that's small and taking its cosine will give you a much larger value. So when we look at, usually we have pi over 6 and pi over 3 as the reference angles, right? So this one's relatively smaller, therefore we should be expecting the larger value. So cosine of pi over 6, as we know, is √3 over 2. Sine of pi over 4 is the same thing as cosine of pi over 4, because again that's just 45 degrees. So we would add this to √2 over 2, and we have a common denominator of 2 here, so you can directly add this, and final answer will be √3 plus √2 all over 2. So this will be our answer for question 2. Moving on to question 3, we have sine of 3 pi over 2. So again, you may not exactly remember, but if you think about it, on the unit circle, really we say that any point on the circle is cosine theta comma sine theta. And so if we think about this, sine of 3 pi over 2 is really going to be, if this is our circle, right, or something like that. So when we talk about 3 pi over 2, that's 270 degrees, so that's somewhere here. And really it's a unit circle, therefore this means that this point over here is going to be 0 comma -1. And if 0 alludes to or represents cosine pi, -1 represents sine, sorry, not pi, 0 here would mean cosine of theta, and a -1 would mean sine of theta. So in this case, theta is obviously 3 pi over 2. So if you can just have that pictorial in your mind, it becomes obvious that sine of 3 pi over 2 is really just the y coordinate at that point, being -1. Therefore this value over here is just -1. And the sine of pi over 2, as we know, is 1. Now this one's interesting. If you have memorized it, you would know the tangent of pi over 2 is actually undefined. But if you're not sure, we know the identity, the tangent of theta is really equal to sine of theta divided by cosine of theta. So if we take sine of pi over 2, that is 1. And if we take cosine of pi over 2, that gives us 0. So really tangent of pi over 2, or tangent of 90 degrees, is 1 over 0. And if you divide anything by 0, that's really just undefined. So really multiplying this by an undefined value, and therefore our overall answer will just be undefined. So we don't exactly have a specific value, so the answer would just be undefined. So thanks for watching.